In other modules, we dealt with the question of how to reduce a fraction when it's too fat. Arithmetic fraction or algebra fraction. We handled them both in the same way. We also saw how to expand a fraction when it's too lean and we need something fatter, more complicated, all without changing the value of the fraction at all. And we asked a question. Why would we want to multiply top and bottom by the same expression, keeping the actual value unchanged, but ending up with a fatter, inflated fraction? The answer? Sometimes we just have to give our fraction a certain denominator. So we have to work to find exactly the right numerator to go with that denominator without any change in the value of the whole fraction. But why should we want to give it a particular denominator in the first place? Let's answer that with another question, an easy one. Can you add these two fractions together? Yes, you can. 1/5 plus 2/5 is 3/5, because you can take one of something and add two of the same thing and get your answer just by adding the numerators. 1 plus 2 equals 3. 3 what? 3/5, because that's what you're talking about. The denominators are all the same. That's the key. The denominators are all the same, and it works exactly the same with algebra fractions. In arithmetic fractions and in algebra fractions, you can add or subtract the numerators all you like, as long as the denominators are the same. Can we add these two fractions? Yes, because they have the same denominators. How do we do it? We add the numerators. And then, of course, we want to simplify the numerator by combining like terms. It's easy as long as your denominators are all the same. Try this one now. The first thing I look for is denominators that are all the same. They are. So I simply add the numerators, which gives me a fairly messy expression, until I combine the terms and get my final answer. But what do we do when the denominators aren't the same? We learned the answer to that in arithmetic. We make them the same by finding the lowest common denominator, the LCD. For each fraction, I figure out what number I have to multiply both top and bottom by to give me that denominator. I do it, and then I take my new fractions and simply add them together. What do I add? The numerators. Why can I add them now? Because the denominators are the same. Can we add algebra fractions the same way? We can. It's going to look a little different with all those letters, but the process is exactly the same. First, we need some practice in finding least common denominators. With numbers, we do a lot of this in our heads. In algebra, we write it out and check it. Let's try it with these. The first thing we do is factor both expressions. You might say we want to find out what the pieces are we're dealing with, and how many of each. From the first expression, we extract a common factor, and then factor the result one step further. The second expression also has a common factor, x squared, and then we factor the remaining trinomial into its parts, which gives us all the factors for each of our two original expressions. Now, for each factor, we have a new question. What is the maximum number, the largest number, of times it appears in either expression? The answer? Count them and find out. X appears once in the first expression and twice in the second expression. The maximum number of times it appears in any one expression? Twice. So we write 2 in the maximum column. X minus 2 appears once in each expression, so the maximum number of times is once. And so on until we have the maximum number of appearances for each of the factors involved. Then, the very simple step of listing each one that number of times and multiplying them all together. And that is the LCD, whether we multiply it out or leave it in factored form as we do here. Sometimes we use this method for numbers too, and it works, but mostly we can do them in our heads. Let's look at another example. This one's easier because the expressions are already factored for us. So all we have to do is count and choose the highest number for the maximum column. And that gives us our LCD. 3 occurrences of X, 5 of Y, and 7 of Z, all multiplied together. Now you have a problem of your own coming up. These are the steps you'll need to solve it. And this is the problem. Follow the steps, get your answer, and then I factor the first expression and find that in its very simplest form, its factors are 3 and x twice and x plus 3. The second expression is a trinomial. I factor it in the usual way and come up with x plus 3 and x plus 4. I line up all my different factors and count the maximum occurrences of each in any one expression. I take all my maximums and line them up, and then put them together and multiply, and that's my LCD. That's step 1 in adding fractions. Step 2, we have to make equivalent fractions with the proper denominator. For example, how do we change 2/3 to something with a denominator of 24? Think of the problem this way, and you'll realize that we do it by factoring the denominator. And then, since we multiplied our denominator by 8, that tells us we have to multiply the numerator by the same number, 8. We do, and we get 16/24 as an equivalent fraction to 2/3. The same thing happens in algebra. We want an equivalent fraction to 3 over x plus 2. What do we do first? Factor that new denominator. That tells us that we've multiplied our original denominator by x minus 3. So we have to multiply the numerator in exactly the same way to get an equivalent fraction. That's no problem at all. We just write it in brackets and make it part of our new numerator. Now go ahead and do this one in the same way. You want an equivalent fraction with a denominator of x squared minus 9. When I factor the new denominator, I find that the old denominator has been multiplied by x plus 3, which tells me that I have to do the same thing to the numerator. I multiply it out using FOIL to get my final answer. Now we're finally ready to use the two ideas together, finding the LCD and making equivalent fractions, because those are the two steps we need before we can add fractions. In arithmetic, to add fractions, we have to find the LCD, make equivalent fractions, and add. In algebra, it's exactly the same, but harder. Watch how it goes. First, we have to find the LCD, and to do that, we start by factoring the denominators. We find the factors, count the maximum occurrences of each in a single expression, and multiply those maximums together to form the LCD. In this case, all the maximums are 1. Second, we use the LCD as our new denominator for each of the two expressions. Look for the factor which turns the old denominator into the new one in each case, and multiply the numerator by that same factor. That gives us two expressions with the same denominators. How do we add expressions like that? We just add the numerators together. That gives us a correct answer, but not a very simple one. Where we go from here would depend on the use we wanted to make of the answer. Sometimes we would multiply out the numerator and collect the terms like this. Other times we would multiply out the denominator too. Right now, we'll leave it this way. I realize that we've barely mentioned subtraction, but that's because there's only one thing to say about it, namely this. When you get to step 3, subtract the numerators instead of adding. That's it. So for the addition or subtraction of fractions, here again are the steps you want to follow. You'll be seeing this kind of thing again and again, so you'll want to find more explanation and examples right away, and more practice problems too. You'll find examples in your textbook, and plenty of problems to work on as well. Be sure that you remember all of the steps in the process, and more important, be sure to use them. Good luck! And if you have any difficulties, you might want to review some similar problems in arithmetic. It sure helps.